Welcome to the second part of this IoT tutorials on IoT and embedded cybersecurity. So in our previous video, we learned how to set up our Raspberry Pi Pico kit and the Pico 2W. So in this video, I'll be talking about the simple IoT project that is titled IoT-based temperature and humidity monitoring and control system. So basically, it's a simple IoT device that enables real-time sensing of environmental condition using the DHT11 sensor, and also it allows remote control of electrical devices through a relay via the internet and mobile devices. Okay. So what are the applications? So it can be applied in smart homes, agricultural purposes, for example, the greenhouse, or you can use it to monitor your poultry or your brooders, your brooding system, or you can also use it to monitor your fish farms, your ponds. You can also use it to monitor your storage facilities. It can be used in air care centers, server rooms, classrooms, offices, and even industrial environments. Okay. Now let's look at the components that are required to build this simple IoT environmental controller. So we need the Raspberry Pi Pico W or Pico 2W. We need the USB cable. Okay, this is the USB cable. We need the OLED, so we're using the OLED 0.9 inches OLED. We're also using the DHT11 sensor. So this sensor measures the temperature and humidity. We need our Maker Pi Pico development kit. Okay, so this is the Maker Pi Pico development kit. And we need a single channel 5 volts relay. Of course, you can use multiple channels, but for this simple IoT project, we're using the single channel relay. Of course, we need our jumper cables. Okay. And now, once we've identified our components, we need to do what is called pin mapping. That is the table that describes which pin of the Pico 2W is connected to our electronic component. So in this case, I've listed all the pins of the Pico 2W. So the GP0 is connected to the OLED SDA pin. GP1 is connected to the OLED SCL pin, and of course the OLED VCC is connected to the 3.3 volts output of the Pico W, and the OLED ground is connected to the ground. The same thing applies to the DHT11. So we're using the GP2 to connect to the DHT11 signal pin, and 3.3 volts to power our DHT11, and of course ground to ground. So we have a passive buzzer on the Maker Pi Pico development kit, which is connected to GP18. So we're using GP18 there. Then the relay is powered with 5 volts. So we're connecting to the V bus of the Pico 2 microcontroller. Then of course ground to ground, and the relay in, that is the signal that controls that receives commands from the microcontroller. So we're using the GP6 to connect to the relay in. So the GP6, the microcontroller sends out a signal from GP6 to switch on the relay or switch off the relay. So this is the hardware design. Okay, so this is our OLED. So this is the ground. So the ground is connected to this ground of the Pico 2 microcontroller. VCC, as you can see, is connected to 3.3 volts. So this pin is the 3.3 volts output that powers any device that is powered by 3.3 volt. Then of course the SCL is connected to GP1. SDA is connected to GP0. All right. For the DHT11, this is the connection. Okay, so we have our signal out, which is connected. The VCC is connected to 3.3 volts of the Pico 2 microcontroller. The signal out, which is S here, so most times they put this symbol S. Okay, so you connect it to GP2 of our microcontroller. Then the buzzer, so it's connected to GP18 of the microcontroller. Okay, and this to ground. Okay. Then we have the relay. So the relay, the signal in, so GP2, GP6, yeah, GP6 is connected to the signal in, all right, and the ground to ground, because VCC to 5 volts, all right. So these are the hardware circuit connection. So using your jumper cables, the groove. So this is connected to groove 1. So if you look at your Pi Pico board, you see GP0, GP1, 3.3 volts and a ground. So you just connect them directly to your OLED. Okay, so GP0 is on groove 1. That's how I'm using groove 1. So they are all labeled. That's the beautiful thing about this development kit. So it's all labeled and easy to use. Then the buzzer, the DHT11. Okay, so we're using this groove 2. Why? Because it has the GP2 connected to this white jumper cable. Then of course our relay is connected to the 5 volt. Okay, so in this case we're using a female to male connector, okay, or jumper cable. So this goes into the relay, and of course we use the header pins on the Pi Pico development kit for the connection. So I'm going to show you next a video tutorial on how to set the connection up. Okay, so we're going to set up our IoT temperature controller. So we have the relay, 5 volt relay, we have the Pi Pico base development kit, we have the OLED, we have the DHT11 temperature sensor, and we have a Pico 2W microcontroller. Then we have our jumper cables for connection. So let's do that quickly. So the first thing is for us to insert the Pico W into our Raspberry Pi, into our Pi Pico development kit. And again, so you check your USB port, then you insert nicely. Okay, so this is done. So the next thing is we're going to connect our OLED. Okay, so the OLED has 4 pins. That's 4 pins. We have the ground, VCC, SCL, and SDA. So we're going to use one of these groove connectors. So connecting the female part into the male headers of the OLED. So first is the ground. Okay, so the ground is usually the black one. So you take your black one and you connect to this point. Then the next is VCC. So make sure you note the VCC position, and the red cable usually is used for VCC. Okay. Then the next is SCL. So SCL, I'm going to hold on that because I need to be sure which of the GP zeros, because our SCL is meant to connect to GP1 and SDA is meant to connect to GP0. So I'll come to my board here and look for which of them has GP0. So GP0 is on groove 1. So you have groove 1. Okay. So I'm going to connect this to my groove. Again, the groove has a clip, so you press it down a bit and you insert it nicely. Okay, so that's done. So on this you can see all the pins are labeled on the Pi Pico development kit, which is very nice. So it tells you the white one, the white connector is connected to GP0 and the yellow one is connected to GP1. Right, so in that case my GP0 which is the white one goes to my SDA, the SDA. Okay, and this, the yellow one, which is my GP1, goes to my SCL. All right, so the connection is based on our pin mapping, which I showed you in this slide. Okay. All right, so for the connection of the DHT11 temperature sensor, you notice it has the positive out and the negative sign. So the negative sign goes to the ground, the plus goes to the VCC, and the out is our signal that goes into our microcontroller. So I'm going to use this groove to female connector again. So what do you need to do? You just take the black one. The black one is ground. Okay, so insert into where you have your negative point. Okay, then the VCC, which is the red one, goes to this point. All right, then so on our mapping, we are connecting our signal output
to the GP2 of the microcontroller. So again, I'll come to my board and check where's my GP2. So if you check on your board, the GP2 is on groove 2. You can see GP2. Oh yeah, it's on groove 2. Okay, so I'm going to connect this point here. Okay, all right, so make sure it's well clipped. Then, so my GP2 is the white one. All right, so it's connected to the white one. So I'm going to take the white button and connect to my signal out of my DHT11. So this is how it's done. Okay, brilliant. So the next thing is our relay. So the relay is the last part of the connection. Okay, so again, the relay is connected to GP6. That is the pin in of our relay. Pin in of our relay. Okay, so if you look at your relay, you have the VCC, ground, and in. Okay, again, so I'm going to use this red one. So this time around, we're using a female to male connector or jumper cable. So the red one goes to our VCC. All right, so I'm going to use the brown one for my ground. Okay, that's fine. Normally it's usually black, but I have a brown. Then I'm going to use the orange for my signal in. Okay, now this relay is meant to be powered by 5 volts from your microcontroller. So the 5 volts is usually this V bus. You can see the V bus. Okay, so I'm going to insert this into where we have our female, either close to the microcontroller. Then the brown one, which is ground, I'll connect to any ground. So we have so many grounds on our Pico board. So I connect to this ground, GND. Then our signal in is meant to connect to GP6. So I'll look for GP6. This is where GP6 is. So I'll put it here. Okay, so with this we finish connecting our IoT temperature device. So we have the OLED, we have the temperature and humidity sensor, and we have the relay.
Thank you for watching, and if you like this video, please don't forget to like, share, and subscribe to this channel. So we'll be focusing more on IoT and cyber embedded systems. Thank you for watching. Bye.